Hey guys, it is Sam with Nexus Workshop, and we're going to start stepping through all the inputs and outputs that are available on the Nexus Ultimate Prop Controller. So the first one we're going to go over is digital inputs. Now, digital inputs are inputs that they are digital, which means that they are a 1 or a 0. They have two states, on, off, high, low. Conversely to that, you would have things like analog inputs or other input modules where the actual input could be either a level from 0 to something with a lot of options in between, or it might be using more of some type of protocol to communicate serial I2C, something like that, or it's actually talking and saying, hey, I found this RFID tag or something like that. So these are the simplest of the inputs. They are digital. They are yes, no. It's switches and buttons. And that's usually what you're going to use it for. It's going to be either latching switches or momentary buttons. Those are the most common, but you're also going to be doing it if you're using something like the little off-the-shelf relay modules that you can get, where they have a relay output for their RFID, something like that, or if you have another prop that you're using, an off-the-shelf prop that has a relay output and you want to take that and connect it up to your prop controller to use inside your system, add some lights, add some other things to it. This is how you could do that. And so whenever you're doing it, there's a concept called dry contacts. Dry contacts means it is just that input pin going to ground. So if I take a button and I connect it, I'm going to connect it from my input pin that I've selected inside the UI. So I select that pin, that's where one wire of the button goes, and the other wire of the button goes to ground. You're going to have a lot of different things that need to go to ground with one of these controllers. There are a couple different ground connections on here. There's a few on each side. But the other thing you can do is you can just pull that out and put it to a rail or twist all your wires together and solder them up, put them on. There's a lot of different like terminal strips and things like that you can use to break that ground out. It's important that all those grounds go together, and that's how it's going to tell what is a high versus a low. Now, there's an internal concept on this board called a pull-up resistor, and what that does is it takes that input pin and it uses a small little resistor internally to make it high. So it pulls it up to the voltage, and then when you take that pin and you connect it to ground, and it has a full pass to ground, it could be a wire, could be a button or a switch or anything else in between, which is just making that electrical path connect. When it has that whole path to ground, that pulls it low. And that's where the controller actually reads. It says, hey, I was a 1, now I went to 0. That's a button push. Now, inside the UI, you're going to see a lot of different, they're labeled as simple inputs. And there are analog inputs in there as well, but also all of your digital inputs are considered simple inputs. And there's a couple different ones. There's buttons and switches and read switches, things like that. Those are all kind of semantic, meaning that they are just how it labels it, how it treats it. So like if I add a button, it says that, hey, by default, when I push it, it's called pressed. When I release it, it's called released. If I add a read switch, I believe it labels it as near and far, because is the magnet near to me or is it far from me? It's also doing a little bit of conversion from that fact that like, hey, unpressed is high, 1, and pressed is low, 0. And sometimes you can think of that backwards. And yeah, but I push the button should be true when push the button makes it go false, right? So the way that we handle simple inputs in the UI takes a little bit off of you and lets you name it what you want it to be. So it's pressed and released for a button by default, but you can change it to whatever you want it to be. Again, that's semantic naming. It's what we call it within the UI so that you can see it and respond to it and tell the system what to do with it. But in reality, that's what's actually happening on that pin is it's getting pulled to ground. Now, the logic on this board runs at 3.3 volts. It is ESP32 based, so it runs on 3.3 volts, but it is 5 volt tolerant on all the I/O, which means that you can hook it up to pretty much anything in the Arduino world, and it's not going to cause any issues. But you can't hook 12 volt inputs up to it. So if I have, again, one of those like car RFID modules, those tend to run on 12 volt, and they have that output. A lot of the time they have the relay, or it just has the 3 wires, and the 3 wires it's going to give you our power, ground, and signal. That signal tends to be 12 volt. I don't want to drive that straight into a pin. I will hurt the pin. If I put 12 volts straight into that pin, it will hurt it. And so that's where you need to use an optocoupler is what you can use to isolate it. An optocoupler, anytime you have something else you're hooking up with voltage to it, you want to do this. So even if I was to say take like another Arduino based prop or something like that, and I, instead of using a relay or something like that to make it a dry contact, I am just taking that voltage off the pin, it's 5 volt, and I take that voltage and it's coming into me. even though it's only 5 volt, because it's different, an optocoupler could be a good idea there. Definitely if I have something where there's a possibility that it's running on 12 volt. A lot of the more industrial sensors are going to be 12 volt or more. Anytime I have something like that, I want to go through an optocoupler. Optocouplers are pretty cheap. What it technically is, and this is a fun fact for you, inside there's a little chip on there, and it literally has a LED on one side and a photoresistor on the other side. And it uses the input to turn that light on, and it uses the photoresistor to take its other output and drive it low. And so that lets you optically isolate, which means there is no electrical connection between these two things. There is no voltage passing to mess it up. It's taken that wet contact with voltage on it and made it a dry contact. I've used that a couple times, dry contact. What that means is it is literally just wire connecting. There is no voltage on it. There's no circuitry on it. It's just a button, a wire, a switch. And that's what you want to be using for your digital inputs, dry contacts. Now, the other way you can do that, like those, again, keep coming back to those cheap RFID car modules. Those have, a lot of time you can buy them with a relay on board. That relay would give you dry contacts, which means, yes, you have circuitry on the other side of it, but it's literally just driving that relay. That relay connects or it doesn't. And so when it connects, that's a dry contact giving me that. It's not giving me any voltage, it's just connecting my button pin to my ground pin, and that's completing my circuit, letting me sense, is it switched or not? That works. One of the things that you've seen industry-wide is a little bit of pushback on the relays and all the clicking and stuff, and you've seen solutions for that. The solution for that in this instance would be to take the relay off and take those wires, land them onto an optocoupler. So you just take the signal and the ground, land it on an optocoupler, and then land that into your board, and now you have a silent input from that relay module, from that RFID module, in as a dry contact to your board, and it's all good. So again, that is digital inputs, buttons, switches, anything like that. You're just connecting the pin to ground, and that's how it's sensing yes, no, is it pushed, is it in the toggled switch state, is it connected? There you go.